Inside silicon, the technology behind everything.
Every time you hear about some new, mind-blowing breakthrough in AI, there are three companies working silently in the background. And without them, the AI revolution that we're all watching, well, it would just grind to a halt. So in this explainer, we're going to pull back the curtain on the silicon pillars that are holding up our entire AI future. It's so easy to think about AI in terms of software, algorithms and massive data sets. But today, we're going to ask a much more basic question. If AI is the engine that's changing the world, what is that engine actually made of? The answer, it turns out, isn't just a bunch of code. And that right there is the core idea. Every single leap forward in AI, from ChatGPT writing a poem to a car driving itself, it all depends entirely on physical silicon chips. And these chips are manufactured with a precision that is almost impossible for our brains to even comprehend. This means that progress in AI isn't just about having better ideas. It is fundamentally driven and, limited by the hardware. Okay, so you might be wondering, why can't AI just run on my laptop or any old computer? Well, that question gets right to the heart of the matter. AI has a very specific and incredibly demanding hardware problem. Think about it like this. A traditional computer chip, a CPU, is like that single-lane road. It is a master of doing things one after the other really, really fast. But AI is a completely different beast. It's that massive multi-lane superhighway. It needs to do trillions of things all at the exact same time. It's a totally different kind of traffic flow. And this whole concept has a name. It's called parallel computation. Instead of picturing one super genius solving a problem step by step, a much better way to think about it is like an army of specialists, 1,000 of them, all tackling their own tiny piece of the problem at the same time. This is, at a mathematical level, how AI actually thinks. The scale here is just staggering. If you actually tried to train one of today's big AI models on a regular old CPU, you wouldn't be waiting for days or weeks. You would literally be waiting for years. Not to mention the insane amount of energy it would burn. It's just completely, totally impractical. And that's exactly why a whole new kind of engine had to be invented. Which brings us neatly to our first pillar, NVIDIA. You see, these guys didn't just build a faster chip. They totally redefined what a chip could even be for. They are the architects of the entire modern AI engine. So what is it that makes their chips, their GPUs, so special? Well, it goes back to that army of specialists. An NVIDIA GPU isn't one big, fast brain. It is packed with thousands, literally thousands, of tiny little cores, and each one is a specialist in that parallel math that AI needs. It's not a Swiss Army knife. It's a purpose-built engine designed from the ground up for one thing, running AI. But here's the real secret to their dominance, and it's absolutely crucial to get this. It's not just the silicon. It's their software platform, CUDA. You can think of it as a special language that only lets programmers talk to NVIDIA's hardware. They spent years making this platform the best and easiest to use. And in doing so, they built this massive moat around their business that basically locks developers in, which is how they ended up with over 90% of the market. Okay, so NVIDIA designs the world's most powerful AI engines. Incredible. But here's the catch. They don't actually build them. For that, everyone has to turn to our second pillar, TSMC, the Taiwan Semiconductor Manufacturing Company. These guys are the master builders who turn all those brilliant blueprints into physical reality. To really get what TSMC does, just look at this number, 3 nanometers. That's the scale they're working at for the most advanced chips. It's a number so ridiculously small that it's almost meaningless to us. Our brains just can't picture it. So let's try to put it into perspective. At 3 nanometers, the tiny on-off switches that make everything work, the transistors, are only a few dozen atoms across. A few dozen atoms. We're talking about a process where a single stray particle, a single speck of dust, can ruin everything, inside factories that cost over $20 billion to build. The level of precision is just operating at the very limits of what physics allows. So how on earth do they pull this off? They are the world's masters of a technology called EUV lithography. This involves using incredibly powerful light to etch these impossibly small patterns onto silicon wafers. Being able to do this reliably with a high success rate and at a massive global scale, that is their superpower. It's why everyone, NVIDIA, Apple, you name it, they all have to go to TSMC. And this quote just captures their importance perfectly. Right now, the real bottleneck in AI, it's not a shortage of brilliant new ideas. It's a physical shortage of manufacturing capacity at TSMC to build the chips to test those ideas. In a very real way, TSMC's production schedule dictates the pace of the entire AI revolution. This brings us to our third and final pillar, a name you've known for decades, Intel. For the longest time, they were the undisputed kings of silicon. Now, their role in the AI story is a little different, and it's really all about the future. They are stepping into the ring as the great challenger, here to shake things up.
And Intel is tackling this with a two-pronged strategy. First, yes, they're designing their own AI chips to compete directly with NVIDIA. But second, and this is arguably the bigger deal, they are pouring billions of dollars into building their own advanced factories, what the industry calls foundries, to compete head-on with TSMC.
Now, this move isn't just about business. You have to understand it's about geopolitics. The whole point is to create a powerful, cutting-edge manufacturing alternative that's outside of Taiwan. It's all about diversifying the supply chain and giving the United States and its allies some much-needed resilience. It's a strategic backup plan.
So there you have it, the architect, the builder, and the challenger. Now let's just step back and look at how these three giants all fit together to form one single, deeply interconnected system. First up, you've got NVIDIA. Their job is simple: design. They're the ones dreaming up the architectural blueprints for the future of AI computation.
Next, you have TSMC, who steps in to manufacture. They take those incredible designs and use physics-defying techniques to make them real, to literally turn sand into intelligence.
And finally, you have Intel. Their job is to compete and stabilize. They're pushing everyone else to be better, while at the same time they're building a critical safety net for the whole system.
You can see now how this is like a three-legged stool, right? They're completely dependent on one another. Take away NVIDIA, and the pace of new AI designs just slows to a crawl. Take away TSMC, well then those brilliant designs can never be built in the first place. And without a strong Intel in the game, the entire system becomes dangerously fragile and concentrated in one place.
And that really is the key takeaway from all of this. When we talk about the unbelievable power of AI, it's easy to think of it as magic, but it's not. It is a marvel of human engineering, built up layer by layer, transistor by transistor. And if you really want to understand where AI is headed next, don't just look at the software, look at the silicon that lies beneath it all.
Inside silicon, the technology behind everything.